Okay, hello everyone. In a new video. In this one we are going to solve an exercise related to energy and the chapters of work and mechanical energy. This exercise was the previous one in the LH and SE terminal exams 2021 first session, exercise number 1. Now the title of this exercise is motion of a sled. A child sitting on a sled slides on a track ABC located in a vertical plane. The system child sled considered as a particle S of mass m is equal to 85 kilograms. Then the moment the mass is given, which means that is related to energy, is at rest at point A at a height HA is equal to 1.8 meters. Then the trick in solving such type of exercises is to label the speed and the distances on the diagram itself. Then here we have that this is 1.8 meters. Now, above the horizontal part BC of the track document 1, S slides without friction, so the moment there is no friction, which means that the mechanical energy of the system is conserved. Now, the horizontal plane containing BC as the reference level for the gravitational potential energy of the system. Then this is the PE level. Now, whenever the object is found between B and C, then the potential energy is given by 0 because it's passing through the PE level. And they are telling us to take G is equal to 10 meter per second square. Now, in number 1, they are telling us to calculate the gravitational potential energy GPE at A. Then let's say GPE at A. Now this is given by the formula mgha. Now the value of the mass is given by 85 and the value of G is given by 10 and the value of the height at the point A is given 1.8. Now plugging this on the calculator, then the value of the gravitational potential energy is given by 1530. Since everything in the SI, then the value of the gravitational potential energy in the SI, which is energy, which is joules. Now, in number 2, they are telling us to deduce the value of the mechanical energy of the system at A. Now, always and forever, the mechanical energy is the sum of kinetic and potential. Now, previously we have determined that the value of the gravitational potential energy is given by that. What about the kinetic energy? So here I have missed something. They are telling us that it is at rest at the point A. So here it's important that to say that VA is equal to 0. Now we can directly say that the kinetic energy is 0. And the reason is given by S is at rest. And at rest it means it's not moving. Then this is equal to 1530. Now in number 3 they are telling us show using the principle of conservation of mechanical energy between A and B that the value of the kinetic energy of S at B is given by that. Now we know that the kinetic energy always and forever can be calculated using two methods, even by the direct formula which is given by half mv squared, or from the conservation of mechanical energy. Here they are specifying that we need to use the conservation of mechanical energy. And this is done because the system is frictionless. Then let's say since there is no friction, then the mechanical energy is conserved, which means that the mechanical energy at point A is equal to the mechanical energy at point B, which is equal to 1530 joules. Now, but we know that the mechanical energy at B is equal to kinetic at B plus the gravitational potential energy at B. And we are interested in determining the kinetic energy at B. Then let's rearrange for the kinetic energy at B. And this can be done by dragging this to the left hand side, so it becomes a minus sign, which means that the kinetic energy is the mechanical energy minus the gravitational potential energy. Now we know that the value of the mechanical energy at the point B is given by that. Now what about the gravitational potential energy at point B? So notice that at point B, S will be here, so, and it's passing through the PE level, so here we can say that GPE at B is 0, and the reason is given by S passes through the PE level. Then minus 0, and indeed the value of the kinetic energy at the point B is given by that. Now we expect, since we have determined the kinetic energy using conservation of energy, then we expect that they would ask us about the speed at the point B. And indeed they are telling us to deduce the value of the speed at the point B. Then we know that the formula of the kinetic energy is given by, then half, since this carry the label B, then the speed will carry the label B, and we are interested in determining this. Then if we rearrange for VB square, it's given by kinetic energy at B divided by half m. Now the value of the kinetic energy is given by that. Now half is 0.5 multiplied by the mass, which is 85. Plugging this on the calculator, then this is given by 36. And here we should be very careful because this is the value of VB square. We are interested in determining the value of VB. Then VB is given by radical 36, which is equal to 6 meters per second. And then let me write here. Then now we have reached number 5. In number 5, they are telling us S continues its motion on the horizontal part BC and stops at the point C. Because it stops at the point C, which means that the speed at the point C is gonna be 0. Now in 5.1, during the motion of S between B and C, the kinetic energy either increases, decreases, remains the same. We need to choose one of these, and remember that we need to justify the correct answer. Now remember that kinetic energy is the energy due to speed. Now notice that S moves from B to C. Its speed at B is given by 6 meters per second, whereas at C it stops, which means that the speed decreases. And we know that the kinetic energy is proportional to the speed. So whenever the speed increases, you expect that the kinetic energy increases. Whenever the speed decreases, kinetic energy must decrease. Because the speed decreases from 6 to 0, then the correct answer would be B. But first, let me justify and say that. So here we have the following. So we are in part 5.1. Since the speed of S from B to C decreases from V at the point B is given by 6 meters per second to V at the point C to be 0, then the kinetic energy decreases. Then remember that always we need to justify. And in this case, the correct answer would be choice B. Now in part 5.2, they are telling us during the motion of S between B and C, the gravitational potential energy of the system, does it increase, decrease, remains the same. And notice that here during from B to C, the height doesn't change, S doesn't go up or down, which means that the potential energy remains the same. However, one can say that since S remains along the PE level, which means that the gravitational potential energy is 0 from B to C, for this reason it remains the same. Then let me say since S remains along the PE level, Oops, let me correct this. And GPE is equal to 0, which means from B to C the gravitational potential energy is equal to 0, then the gravitational potential energy remains the same. Now in 5.3 they are telling us the value of the mechanical energy of the system at C is given by. Then we need to calculate the mechanical energy at the point C. Mechanical energy always and forever it's the sum of kinetic and potential. Now we have justified that this is equal to 0 because it's on the P level. Now, and it stops at the point C, so we're gonna say that it's given by half mv squared plus 0, so this is at the point C, which is equal to half multiplied by 85 multiplied by 0 to the power 2 plus 0. This is given by 0, so the correct answer in this case would be A. Now in 5.4 they are telling us the loss in the mechanical energy of the system as Earth between B and C is given by. So remember, always the loss means the initial minus the final. Then let me say mechanical energy loss so here we have two mechanical energies. Now this is the initial and this is the final. Recall that whenever they tell us loss, the decrease or the difference, this is initial and this is the final, except for whenever they ask for the variation, which is delta mechanical energy, then this is given by the final minus the initial. Now here S is moving from B to C, so this is the initial point and this is the final point. What does the initial point represent? It is the first point passing through, which is the point B, and C is the final point, so this is B and this is C. Previously we have determined the mechanical energy at the point B and it's found to be 1530 joules. Minus the mechanical energy at the point C, which is calculated to be 0. And this is equal to 1530 joules. And in this case the correct answer would be B. And let's recall in which form is this energy loss, in the form of thermal energy or heat. So that's it for me in this video guys. See you soon in a new one.